You are with Cape Talk.
Views and News with Clarence Ford.
9:33 on this beautiful Friday morning in the Mother City. And welcome to Views and News through till 12 o'clock with me, Clarence. A very big appointment he is. We're talking about the Naked Scientist, Dr. Chris Smith, medical doctor and a scientist, and he's here to answer your questions as per usual. Welcome, Dr. Chris Smith, lecturer at Cambridge University. It's good to have you back.
Morning, Clarence. You know, I'm buzzing this week because not only is the sun shining and it's a lovely day, and I'm going to also have a nice weekend off. I had the most fascinating interview yesterday with a couple of surgeons who've achieved a first for Britain. It's not the first around the world, but it's one of the first, but it was a first for the UK. And that was our first baby born from a transplanted uterus.
Wow.
And this is
yes.
25 years of effort, and no relative of mine, but Richard Smith, who's the guy who's pioneered this, was gushing when he was explaining to me what they've done. But they actually managed to move a uterus from a sister who had one to her sister who didn't have one. She had an inborn problem that meant she was born without a uterus and therefore no prospect of having children of her own. Her sister, Amy, gave Grace her uterus, and this was done a couple of years ago. It took a year to get the immunosuppression right and to make sure all the other problems were ironed out. Then they put the embryo back. She got pregnant and the baby popped out this week and is a healthy, bouncing baby. And they haven't told me whether she's going to carry on and have any more babies yet, because they can keep the uterus in for up to 5 years. Don't want to go beyond that because you have to keep these people immunosuppressed, and that's not good in the long term if you can avoid it. So they may continue with another pregnancy or may elect to remove it in 6 months' time when everything's settled down. But a wonderful outcome and just amazing what modern medicine can do, isn't it?
Absolutely. It came through on social media yesterday. We celebrated a very significant moment for humankind. Let's go to Royston's question. Anecdotally, he says he's seeing an increase in cancer. Does the real statistics kind of point to that as well? And maybe on the cancer question, there's another question in from Lou. Dr. Smith, what is the underlying causes of colon cancers and what treatments are available?
Right. Well, on Royston's point first, if we look around the world, are more people getting cancer? Well, the answer is the numbers do appear to be going up in some respects and down in other respects. But in general, there is a trend upwards. Is that a worry? Well, we're all living longer. Most countries on Earth have seen an increase in life expectancy, and age is the biggest risk factor for cancer. So because we're living longer, we're living long enough to get more cancer. So to an extent, there is that. But the thing that's got scientists worried is that some cancers are increasing disproportionately. When you take into account an aging population, there are some cancers that you would expect to increase by a certain amount, but the amount they've gone up is greater than that, which argues that something else is at play. There's also a worrying sign that some cancers are occurring at an earlier age than they historically did. And colon cancer, the other question, is one of them. Now, we don't know why this is happening, but the effect does appear to be real. And in the UK, for example, we've seen an uptick in cases, and there is some evidence to suggest that it might be down to diet, and that the dietary effect might be that certain foodstuffs are selecting for certain microbes. There are certain forms of E. coli, for example, which tend to be cropping up more often in the guts of people who have colon cancers. And this has got people wondering whether diet selects for a certain microbiome, and that microbiome increases your risk of cancer. So there's a lot going on looking at this at the moment to see whether the effect is real. It does appear that there is an increase in numbers of some cancers, and there are some theories as to why that might be, but it's early days, and so we need to do a lot more studying yet to find out exactly whether this is real or just an anomaly in the data, and if it is, what the biology that underpins it is. Colon cancer, the one I explained, yes, that's always been a common cancer, but it is increasing, and we think that an element of the increase in risk for that at any age is probably dietary as well.
Let's go to George. George on the line from Somerset West. Welcome, George.
Hi, quick question. Sometimes if you have a couple of glasses of wine and you go to bed, you sleep like a baby. Other times you go to bed and it's as if that alcohol is called that bad sugar because you get like a sugar rush. And you can't sleep and you want to run around the house all night. Why does that happen?
George, that's a really bad line. I did get it. I don't know if you got it, Chris.
Yeah, I mean, in summary, for those who may have struggled with that, the question really is that sometimes you have a bit of wine before bed and you sleep like a baby. Other times you seem to have quite a restless night. And George speculates that might be because of sugar in the wine. There's a number of factors at play here. Alcohol is what we call an excitotoxin. Now, what that means is that when the alcohol breaks down in your body, it breaks down via a metabolic pathway that turns it into a range of things before it becomes vinegar that you wee out. And those things that it turns into along the way can act as a poison, an inflammatory chemical, and a wake-up signal for brain cells, excitotoxicity. So when you drink heavily, you generally have disturbed sleep because your alcohol level gets metabolized into these excitotoxins that then start to activate certain bits of the brain, and this happens with a lag, and so it tends to coincide with the middle of the night, and it may wake people up. So people do find after a bit of a session they may not sleep quite so well. There's probably a sweet spot between having some alcohol that gets the depressive effect of the alcohol, which damps down nerve activity and makes you feel calmer and more sleepy. But if you overdo that, then you'll start to dominate, the effect being these excitotoxic effects that may wake you up. Why does this happen more with some beverages than others? Well, alcohol isn't just the only thing in a glass of wine. There's a very complex chemistry that's going on in a wine bottle or in a bottle of spirits that doesn't stop as soon as you've stopped making the wine or making the spirits. The chemistry continues to evolve. There are chemical reactions happening in that bottle of wine or in that bottle of spirits, actually, for a long period of time. And this is why bottles of wine have a shelf life or a bottle age. Some wines age well, some need to be drunk young, because the winemakers know that the conditions and the chemistries and what they've put into their wine, they know, and based on instinct and experience, how those reactions are going to continue and how they're going to change the character of that particular drink. And that's why some things do tend to improve with age, but others really don't. And alongside the chemicals that give nice flavours and textures and mouthfeel in these wines, there will be other chemical reactions that produce other effects in the body. And some of them may also act as these so-called excitotoxins, or may be quite headache-inducing. Some of these more complicated chemicals might make you feel a bit squiffy and may also irritate your stomach and also cause dehydrating effects and so on. So it really comes down to what proportion of those are in the wine as a total, and therefore how much dose you've had, and that will have a knock-on effect for how well you sleep it off afterwards.
Let's go to Anne's question. Anne says, Dr. Chris, we grew up on sunflower oil. Now, seed oils are getting a bad rap as being unhealthy. What is the reason for certain oils now being regarded as less healthy to cook with than other more expensive oils? And is there any truth to these claims? Thanks, Anne.
This all sort of stems from about 30 or 40 years ago, when people began to point the finger at animal fats and said, these things fur up your arteries and they increase your cholesterol level when you eat lots of saturated fat. Therefore, we should switch to unsaturated fats because these do not appear to be linked to elevations in cholesterol in the same way. Where do we get those from? Well, look, plant fats, they're probably really good. Let's switch over to sunflower oil and that kind of thing. So they went that way. And it's certainly true that unsaturated fats, these are, when they're unsaturated, what that means is that the carbon chains that make up the fats in certain places don't have single bonds, they have double bonds. And that makes the carbon chains kinky. And if they're kinky, they don't stack together quite so tightly. And this means they stay oily rather than as solid lumps of lard. And they're thought to be health beneficial in some respects. But there's evidence that certain of these unsaturates are more healthy than others, and this is based on epidemiology and supported by medicine. And when you look at the populations around the world who seem to have the lowest risk of diseases linked to a poor diet, like a high saturated fat diet, heart disease, stroke and so on, you find that people who tend to have a lot of olive oil monounsaturates and a lot of fish oils in their diet tend to do better than people who have a very high representation of saturated fat or some of these other plant fats. One of the other reasons the plant fats have got a bad rap is because people thought, and especially in industry, in the food industry, they thought, right, people love plant-based stuff. This is viewed as really healthy. But if you've got some sunflower oil, you can't really spread that so easily on your sandwiches. How do we get around that? Well, what we'll do is we'll chemically modify it by injecting a little bit more saturation into it, so it's a sort of halfway house. This will make it spreadable like a margarine and still have all of the perceived health benefits of the plant-based origins. Unfortunately, doesn't work like that, because when we manipulate the fats in that way, there's evidence we might actually be making them far more unhealthy, and this is partly where this stems from. So the bottom line is, look to nature, look to epidemiology. The Mediterranean diet, lots of fats, lots of oils, but they're olive oils, they're monounsaturated, lots of oily fish. This appears to be consistent and compatible with very good health and good brain health as well. So those are the ones to go for. Substituting lots of plant-based fats isn't necessarily an immediate panacea for a saturated fat from red meat diet and won't necessarily buy you lots of health benefits. And that's really where the equation's got to so far.
Let's take a voice note, Joe. Voice notes, text notes, questions for Dr. Chris Smith, the Naked Scientist, 072-567-1567.
Môre, Clary en Dr. Smith, as far as Isofa Wusterman. Dr. Smith, mosquitoes, why do they come after you when you wear certain deodorants? Yeah, I've noticed when I wear a certain or spray a certain deodorant, then mosquitoes are prone to attack me. And yeah, I'm not a roll-on guy because I get like little bumps under my armpits. But yeah, are mosquitoes attracted to certain smells of deodorant? Have a good job. Bye-bye.
Great question, and the answer is yes to all of the above. Mosquitoes, flying hypodermics by their other name, track you down using a combination of ability to detect heat, because they know that the likely source of a blood meal is something alive, and something alive is something warm. And second, they use the smell of you. One of the strongest smells they track down is carbon dioxide, because we breathe that out, and so a strong source of carbon dioxide means a living, breathing thing, and that probably means a meal. The other is that they're very sensitive to a spectrum of a constellation of chemicals, volatile chemicals that we leach off of our bodies. Everyone has a particular chemical aroma about them. This is why dogs come and sniff at us, and dogs can tell one of us from the other. We all have this unique combination of odours and odorants which come off of us into the air around us and produce a sort of halo around us. And some of those smells are extremely attractive to mosquitoes. Others are actually a deterrent to mosquitoes, which is why we think some people always get bitten and others always get avoided. My wife is the biggest mosquito magnet on earth, which means if I go out, I never have to worry about being bitten because they leave me alone. They're all round her. If they're left with no choice, they eventually reluctantly will prey on me. So some of us are lucky that we have a particular odour profile that does not attract mosquitoes as strongly. Others appear to be more attractive, and it will come down to certain chemicals coming off of us that mosquitoes are sensitive to and can find. Now we can, as the question alludes to, augment our chemical profile when we use deodorants and scents and perfumes. Some of those mosquitoes love, so you will make yourself more attractive. And you can also reinforce the attraction with certain colours. Mosquitoes are visual. They don't have so they wouldn't be reading a novel, for example, but they have eyesight that's good enough to spot certain patterns that earmark, this is a potential meal waiting for me. So colour scheme and the smells we have will make you more attractive. And then at the opposite end of the spectrum, how do mosquito repellents work? Well, they fill you up with a smell that stinks to a mosquito, like DEET, for example, and the mosquitoes actively avoid going near it. So that's one way of masking your natural colours and flavours with things that the mosquito finds so unappealing, it flies the other way.
It is the Naked Scientist with us through till 10 o'clock this morning, and let's cram in another question, Joe.
It's a question for Dr. Smith. I have heard talk about phthalates and parabens as possible causes of cancer. And apparently, they are found in shower gels, things like that, and phthalates are found in perfumes. So, what are your thoughts on their linked cancer? Thank you.
Another very interesting question, and in fact, I spent this week also talking to the guy who 20 years ago, Richard Thompson, coined the term microplastic. So if you tune into the Naked Scientist podcast on Tuesday next week, you can hear Richard talk about his experience over the last 20 years of researching microplastics, now nanoplastics, and their health impacts of things like the question that's being asked here. So that's coming out on Tuesday. What's being referred to here are chemicals that are in plastics, but they're not themselves plastics. Because when we make a plastic, the chemistry of the molecules, the polymer, might make a plastic that's not ideal for our circumstances. We want something that feels nice, sounds nice, bends nicely. And we add to the plastic additional chemicals that interleave themselves between the molecules, which are the polymer, and they give an additional characteristic to the plastic. It's a bit like if I put oil in my car engine. I need a small amount and it makes the engine run more smoothly. You add these chemicals to the plastic and they make the plastic work in a better way for the intended use case. And some of them are linked to health impacts. Now, what happens when they're in there? Do they stay put? The answer is they don't stay put, and that's potentially the problem. When you heat the plastic up, when you grind the plastic up, or just when you put things in contact with the plastic, these chemicals, just by chance, will slowly leach out. And this is why your plastic drinking bottle, for example, becomes quite brittle with age. You use it for a few years and then suddenly it starts to just break. It's not bendy and nice to feel anymore because all those chemicals have moved out into the water in the bottle and you drunk them all. What are the health impacts? Well, because these molecules occasionally look like some of the molecules in the body that we use for, say, hormonal signaling, hormones, estrogen and so on, there is also an association between exposure to these chemicals and certain cancers that are driven by these hormones. Breast cancers, for example. They're called endocrine disruptors. And so there are association studies showing that these chemicals may be linked to certain health problems. And as a result of that, there is legislation in place that should keep plastics that contain these chemicals out of the use of foods, kitchens, healthcare products and so on, but they're regarded as relatively safe when they're used for other use cases where you can't really get around using them because you want a plastic that behaves a certain way. There is a fly in this ointment, though, which is, as one lady who works for the EU or works on research projects looking in the EU pointed out to me about a year ago, we've got a lot of recycling that we're trying to do with plastics to try to minimise plastic pollution. The problem is that we're not very good at separating the plastics that can be in contact with foods, foodstuffs, and in health situations from the stuff that definitely shouldn't. So there's a contamination that goes on. So although we're trying to be diligent, we're not very good at it, and we're probably being exposed to lots of these things. And one has to ask, what are the long-term health consequences? At the moment, the jury's out.
And another WhatsApp question.
Hello, Dr. Chris. I read that saccharin is being used as an antibiotic to take the place of those antibiotics that are unable to be used for those super bacteria. How would that be used?
There is a study which suggests that certain things like saccharin can have antimicrobial qualities. In fact, I think that story is only just emerging. I haven't had a chance to read it yet, so I can't say exactly what the mechanism is, but what I can say is more generally and more broadly how this sort of works. And the way in which this generally works is you have molecules which, although we're using the saccharin as a sweetener because it happens to be the right shape to bind with the things that detect sweetness in food when we put them into our mouths, other bits of the molecule can have activity against other organisms by binding onto them. And so they're not worried about it from a sweetness point of view. It's a totally different mechanism of action for the same molecule. And we're finding this increasingly, actually, that there are drugs that we invented them for one purpose, but we're discovering they may be useful in a totally different way. And we're now, because of electronic medical records, beginning to accrue a lot of data where you put patients on a drug for condition X, and then you follow up and you find that patients who in that group would normally also get disease Y are much less likely to get disease Y when they're on drug X. And you can then sort of rationalize that and say, well, I reason that this drug as a side effect seems to be reducing the risk of this condition. And so it's a so-called off-target effect. So we're finding new uses for old drugs. And I think this is another example of a drug or a chemical which you invent it for one purpose, but then discover it's actually got other properties as well. But what I will do, I have heard the mention of it being used in an antimicrobial context. I will go away and bring that back next week for you with a more in-depth analysis of that, because I'm not familiar enough with that literature to give you a clear insight into the antimicrobial properties of saccharin, but I will have a look at it before next week.
And we'll have to wrap it there. Time just flies when we chat with a naked scientist. Thank you, Dr. Chris Smith, lecturer at Cambridge University, and of course he joins us every Friday just after 9:30. Those questions that keep you awake at night, he answers them.
You are with Cape Talk.
Views and news with Clarence Ford.